Hi, everyone. It is Morgan here with Positive Approach to Math. We are rounding out our last lesson of our algebraic expressions topic, and we are going to cover evaluating algebraic expressions today. As always, we'll begin with a little bit of information to get you started. We will dive right into some examples and then round out with a summary and some helpful hints and leave you with a couple problems to try on your own. Uh, Keep chugging along. You're doing a great job. You are setting the tone for yourself as you navigate your Algebra 1 journey. All of these skills are really important as they're going to become second nature, and you're going to utilize them in all of the following lessons and topics that you're going to cover, not only in Algebra 1, but in your math classes beyond. So let's talk about evaluating algebraic expressions. So this is when we have an algebraic expression, 3x plus 2, but then they're asking you evaluate it when x is 7 or whatever x might be. So they're assigning a value for your variable that are given or the variables that you see present, okay? So whenever we have an algebraic expression, if we give you values of the variable or variables in the expression, we want you to substitute it in. So say, okay, x is 7. We're going to take out that x and substitute in 7 for it. And then we're going to evaluate it. And how we're going to evaluate it is we are going to use order of operations, which I use PEMDAS for. Some other people use G instead of P, but dealing with all of your parentheses first, simplifying your parentheses, taking care of any exponents. Remember multiplication and division, we work left to right. So whatever we see farthest on the left, we start with. Wipe out all of your multiplication and division, and then we end with any addition and subtraction. Once again, work left to right. So PEMDAS or order of operations is very much a pre-algebra skill. Maybe you started your Algebra 1 reviewing it because it comes up in topics like this. So I have 4 examples to go over with you, and we're using the same variables in all 4 of them. So this is one way you might see evaluating algebraic expressions. And why we do this is really for when we get to our word problems or application problems. We give you an expression and we want to know the cost when you buy 5 bananas and 4 apples, you can substitute into your equation that you might have. So what I'm telling you here is that W, whenever you see the variable W, it's really going to be equal for these 4 problems. It's going to be equivalent to the value 2. X is going to be equivalent to -3. Y is equivalent to 1. And Z is equivalent or equal to -4. Okay. And so what I did here is I just put them out instead of giving you problem A and saying 7W minus 4, let W equal 2, and rewriting it every single time. I just put it at the start. So what we're going to do is we see this first problem. We see a W. So that tells us we're going to take out W and we're going to substitute in what W is equivalent to, which is 2. Okay. So I say everything else stays the same. And when you substitute that 2, this is going back to what a term is. 7W is a term that's multiplied together. So rookie mistake number 1 in this lesson is that does not, when I put the 2 in, it does not become the number 72. A lot of people fall for that. It becomes 7 times 2. And so to make sure I don't accidentally think of it as 72, I always put it in parentheses so I know, okay, I'm doing 7 times 2. And then we're going to do -4. Bring down that -4. So I swapped out my W. I plugged in 2. That was really saying 7 times W. So now it becomes 7 times 2. Okay, and now we're going to evaluate it. We want to get a singular number. So we don't have any really parentheses to simplify. We don't have really any exponents. Multiplication and division, we do see multiplication here, 7 times 2. So we're going to do that first. That's going to leave us with 14. And then we bring down that -4. And then we'll do 14 minus 4. We didn't have any more multiplication or division, so we're left with our addition or subtraction. In this case, we have subtraction. 14 minus 4 is 10. So our final answer, this entire thing is equal to, I want to circle it, 10. We'll do a little box. There we go. Okay. Letter B, we have two variables there. We have y. I'm going to put that in orange to match my y. And we have x. I'm going to put that in pink. Okay. So what we're doing here, that 5 gets brought down, parentheses, brought down. Y is 1, so I'm going to plug 1 in, minus x is -3. So don't think, oh, there's already a minus there. There's already a negative there for the 3. I just have to carry the 3 down. That's rookie mistake number 2, right? So you have to write this exact number regardless of what symbol's there. So we're going to be doing -3, okay? Now, if you wanted to put that -3 in parentheses, so be it, right? You could have done that, and you would have been fine there. You're going to multiply. Okay, now we're going to simplify. So I do see parentheses. So I'm going to condense everything in my parentheses. So I'm going to take care of this first. Okay, 1 minus -3 becomes 1 plus 3, right? 1 plus 3 is 4. Whoopsie, I'll change my color for you. So that's going to become 5 times 4. 5 times 4 is simply 20. So that entire expression, when y is 1 and x is -3, simplifies down to 20, okay? And the last two, we'll go right there. Okay, we have a z here. Z, if I can highlight it tiny, is equal to -4. And we have a fraction, which a lot of us don't like fractions, but it's going to be okay, I promise you. So 3, I'm going to remember that's 3 times z. So when I plug in -4, I'm going to put it in parentheses. So I know it's not going to be 3 minus 4. It's going to be 3 times -4. I'm going to bring over the +6 exactly as I see it. Draw the fraction bar exactly as I see it. Draw the 2 exactly as I see it. My advice when you have fractions, whenever you have fractions with PEMDAS, is think of the numerator as one thing in parentheses and the denominator as something else in parentheses. So simplify the numerator using PEMDAS to be a single number. Get it to be a single number. Then simplify the denominator using PEMDAS to be a single number. And then at the end, you're going to a fraction, just is really division. So you're going to divide the numerator by the denominator. Okay? So let's do PEMDAS. So we're just kind of focusing. If I could, I would cover up that 2. We're just, whoopsie, wrong color. We're just going to focus on this numerator. So we don't see parentheses with multiple things inside. We don't see exponents. We do see multiplication. So we're going to do 3 times -4, which will give us -12, plus 6, bring that down, all over 2. -12 plus 6. We're still working on simplifying that numerator. -12 plus 6 will give us -6, all divided by 2. We condensed that numerator to a singular number. That denominator is already a singular number. So once your numerator is a singular number and your denominator is a singular number, you're good to go. You're going to divide those two things. So -6 divided by 2 is -3. So that would be our answer for letter C. So we substituted in what z was equal to, and we simplified the numerator first using PEMDAS. The denominator didn't need to simplify in this case. And then we divided the numerator by the denominator. Okay, last one, letter D. Looks like we've got 3 variables, and it looks like we're going to have some exponents here. All right. So we have x, which is that color. We have w, and we have y. All right, lots happening here and lots to talk about. So Up to you. When I substitute these in, I am going to put them in parentheses. X is -3. So I'm going to take out this X. I'm going to plug in -3, and then I'm going to square it. I keep that squared. Just bring it down. Okay? Plus W is 2. Bring down that squared. -2, parenthesis 1 squared. And that's why I like the parentheses. I like them for those negatives, that -3. I'm going to talk about that. But I like it for this last term. So you know the thing that you're squaring is just the 1. There's a difference between this, what I have written, and that, what I just wrote above. So the only thing that's being squared is that y, right? So it's saying take y, square it, and then multiply it by 2. It would have had to been written like this if that 2 should be glued with that y and then squared. Okay? Whoopsie. All right, so no parentheses with multiple things inside, but we do have exponents. Okay. -3 squared. You're doing -3 times -3. Rookie mistake. Are we on to number 3? A negative squared is not negative. A negative squared is always positive. So if you're using your calculator, this is why I put the parentheses. If you did not know what -3 squared was and you needed your calculator, you need to put those parentheses around that. So you want to make sure you're doing -3 times -3. Now, hopefully you know that a negative times a negative is a positive. So that's going to leave us with +9, okay? It would be wrong if you wrote -9. So any negative number squared, any number squared, positive or negative, is always positive because you're either doing positive times a positive, which is positive, or negative times a negative, which is positive, okay? So that's our first exponent. We have 2 squared. 2 times 2, or 2 raised to the second power, is 4. And now we have 1 squared. 1 times 1, or 1 to the second power, is just 1. I'm going to bring that -2 down and then put that 1 in parentheses still, so I know that it has to be multiplied. Okay. Now, looking here, do not start by doing 9 plus 4 and then subtract 2. You have to wipe out any multiplication or division. So do you see any multiplication or division? The answer is yes. -2 times 1 is -2. And I'll bring everything else down. I forgot to draw my arrows. Now check. Do you see any other multiplication or division? No, we see addition and subtraction. And so we're going to work from left to right. So we're going to do 9 plus 4, which is 13. 13 minus 2, which is 11. So our final answer here should be 11. Okay. So those were our examples. Let's talk about some of these helpful hints. When we are evaluating expressions, you substitute your values in for your variables first. Okay, we want to do that first. Whenever you see a number and say you're substituting a value in, remember you are multiplying, right? So it becomes 7 times that value. It does not become 72. It would become 7 times 2, or whatever your value is. So I always like to put it in parentheses to indicate that 7x was really 7 times x. Make sure you use your order of operations. So whether you think of it as PEMDAS like I do, or you have a different acronym to remember, that you're doing your grouping, your parentheses first, exponents, multiplication and division, we work left to right, get all the multiplication and division out of the way, addition and subtraction last, left to right. And then just finally, take your time and work carefully. It's really easy to make a single little tiny mistake that will throw you off. So really just take your time and say, okay, let's square this. Let's think about this. -3 squared, is it going to be positive? Is it going to be negative? Let's not rush it, right? So just take your time and work carefully. So I left you with two sets of U tries. So there's still just six problems, but this is what I was talking about kind of at the beginning. So here for 1, 2, and 3, I'm telling you, okay, for number one, you're using X is 5. For number two, you're using K is -3. And they're specific for each problem. For number three, you're using this. Okay. Whereas for 4, 5, 6, you're using this information for all three of them. So it's not changing. So you're using X is 5 for number 4, 5, and 6. You're using Y is -2 for number 4, 5, and 6. And then you're using Z is 3 for number 4, 5, and 6. Remember, when you have a fraction, treat the numerator as a set of parentheses, simplify that numerator using PEMDAS to a single number, simplify that denominator to a single number, and then divide your two numbers. Okay, this is going to round out our algebraic expressions. We'll be moving on to our next topic. If you would like to check your work, there's going to be a link. You can gladly click on that link and it will lead you right to an answer key of those six problems. If you need some extra help or you get something wrong on your answer key and you need a little bit of an explanation, you can't find where you went wrong, there is a link leading you to a video breakdown of those six problems. It was really great working with you for algebraic expressions. I can't wait to continue our algebra journey. Keep up the great work.